Well, hello everyone. In this tutorial, I will go over Hazelcast, which is a famous Java-based cache, basically an in-memory data grid, and that is compatible with Spring Boot framework. We will look at the setup, specifically in a multicast configuration, and how the servers are communicating with one another, and the corresponding packet analysis. So for the agenda for this tutorial is a general Hazelcast overview. What are the prerequisites you need before you can follow the tutorial? A sample Spring Boot application, its architecture and overview. Then the corresponding multi-class setup, that is what configuration we need to do in order for Hazelcast to be set up in a multicast configuration mode. A demo associated with that setup. And that will also include packet analysis and how the servers are communicating with one another. And in the later session, we'll look at the specific application components and code overview. As a general information, this application we're going to review is a simple REST-based service implemented in a Spring Boot that's going to cache some information from a database in a multicast setup. And lastly, we will look at the architecture patterns. That is, the patterns in which such an architecture is supported, and also the use cases in which such pattern should not be followed. So what is Hazelcast? Hazelcast is an in-memory data grid. It is basically a cache, and it's open source. It's based in Java, and it's compatible with the Spring Boot framework, and hence it provides an implementation behind the framework. So what it does basically, if there are developers who are familiar with how to develop their application using Spring or Spring Boot, can use the framework and the standard classes and interfaces available there to communicate with the corresponding Hazelcast implementation behind the scene. It is one of the implementation. There are others as well. So in this tutorial, we'll just focus on this Hazelcast. So prerequisites. What are the things you need before you can follow this tutorial? You have to have a basic understanding of Java JDK that you should be able to compile the program and run it. Be able to edit the program, understand the structure in Eclipse, which is an IDE, the Integrated Development Environment, famously used for Java-based application. Maven, this is a build environment, the build configuration, how the Maven pom.xml is defined, and Maven is used to execute different tasks within that pom.xml configuration file. Behind the scene for data storage, we'll be using MySQL DB. The application will communicate with this database to load the data and cache it. Wireshark, which is the traffic and a packet analysis tool, we'll use that for analyzing the server to server and server to multicast packet as the configuration is set up, how the data is being exchanged between these different entities. The Spring Boot, you have to have some familiarity with the Spring Boot application, that how Spring Boots generally are developed using a standard template provided to you, and use that to basically develop your components to run autonomously in either microservices or a standalone configuration. And correspondingly, we will be providing the code and the description below in the video. All right, so let's look at the go back to the agenda. So let's look at the sample application architecture for the Hazelcast. So the configuration in which I'm going to have the Hazelcast setup will be this, as you can see over here. There will be two servers or two machines that will host the Hazelcast Spring Boot application, I will directly run them in Eclipse. And this one is 192.168.150 and 192.168.1.1.1. So two servers, machines, physical machines, I'll be using to run the servers. This is the router configuration. And the multicast address will be 224.2.2.5 that we will use. The servers will use this address to inform and be part of a cluster, discover one another. They will not directly communicate with one another, and we'll see how they discover one another, and then they will form a cluster, and then they start caching the information and replicating the cache information from one node to the other node. Behind the scenes is the MySQL database where the data will be stored. Since these REST services are mostly, say, run in Apache Tomcat, so this will, the Spring Boot will use the 8080 Apache standard Tomcat port over here. And this one, I'll try to run two instances, one on 8080 and one on 8090. The port that you see over here are the Hazelcast communication port. There's a Hazelcast communication port 5820. I'll use one over here, and then two separate ports for the two instances to not cause the clash. We'll use over here 5801 and 5802. And the outbound port here is used for server-to-server communication. And we'll see that in the demo how they are being used as we do the packet capture. Now, in order to run the program, as I said, I'm using two separate machines. So this is 192.168.1.1.1. So I'll be running this instance. So let's just let's start the Wireshark first. So this is the Wireshark. And the configuration, this is the packet capture filter that is going to capture the packet, anything going to this server 111 or from this server with certain port ranges, and we are covering all the server as well as the outbound port ranges for both source and destination, and correspondingly we are also covering the port ranges and the address for multicast channels. So let's start the so now the Wireshark is started. What's capturing is the standard service discovery protocol, so that's not what we are interested in. Let's start the server. So this is again on 1111, and the same configuration is on 1150. So here you go. So I'm starting in Hazelcast instance, and it's going to read the data and create one server in the cluster. It is going to use this 224.2.2.5, which we saw in our multicast address, is the one that we are communicating. And it's using 54320 as a multicast port to listen to. And it created one cluster over here. You can see one server in one cluster, 5801. 5801 is the port on which this Hazelcast instance is listening at. And these are the port it's going to use for internal Hazelcast communication. Oh, we'll see when I start another instance of Hazelcast. So this is one server that has started. Now coming back to machine 150. So this is the Hazelcast on 150 within this Eclipse. So let's start the Wireshark over here. The configuration is pretty much the same, except that instead of 111 here, it's using 150 for source and destination. Same port range to capture both the server to server as well as multicast addresses. And also so this is the multicast addresses, and this is for server to server and just to the server communication. So let's start the Wireshark. So the Wireshark is started. As you can see, it hasn't captured anything because over here also this the server over here is communicating with the same multicast port, and the same multicast address. However, it's using 5820 just for distinction and to separate this traffic from the other traffic. So this one is using, these two are going to use 5801. So I've started the 5801. Now I'm starting the 5820 on this server. So let's start this server. And as soon as it starts, you will see both this Wireshark on 1111 as well as here will start emitting packet capture addresses. Packet as it starts coming in, they will start capturing. So let's just give it a moment. And the Hazelcast servers will also show that okay, so now you have two Hazelcast servers running in, the original one on 1111 and listening at 5801, the other one at 5820. So, and you will see that it starts basically capturing, communicating with one another. One thing I forgot to mention over here is that when the server starts, it sends an IGMP message, which is Internet Gateway Group Management Protocol v3, and it's on this address. What it is telling, what this machine is telling the router is to join this multicast, that this machine is interested in these multicast addresses, and anybody who joins it, this multicast addresses will become a part of the cluster. And these two, this one is the port that's being used by this machine for the multicast. Similarly, if we go to the other Wireshark, this one also now has the from machine 150 has IGMP v3 to this address, asking to join this group 224.2.2.5 for multicast, and again using the same port. Now, if this port is different, then these servers will not form the part of the cluster. So if we look at, without going too deep into the code, if we look at it, there are certain configuration. One is the cluster name, and the other one multicast address and the multicast port. They have to be the same across both the Hazelcast instances, otherwise they will not form a cluster. If I go over here, you will see this instance is also using the same Hazelcast cluster name as well as multicast port and the multicast address, IP address. And after the IGMP v3, this one, since it started waited for some time, there was no communication. Then now when the other server started, there's communication going on between 111 and 150. Once the servers discover one another, they directly start communicating with one another. And as you can see, this one is using 5801, while the other one is using 5900. So if I go back to the other Wireshark, which is running on 150, here you will see it will show you the same communication. So as you can see, this one is also reflecting the same information, 192.168.150 to 111 and 5900 to 5801. So the server-to-server communication are going to use the main port of one of the servers and the additional outbound port for the other servers. Okay, so let's look at the what's going on within the Hazelcast itself. So it started with one server, and then it reported that it has another member which has joined this. Similarly, if we go to the other Hazelcast instance, when it started, you see that it was already a member in that cluster, so it started as a second instance. So this is the second instance for that Hazelcast server. Another thing you will notice is when this server is started, this message I'm printing out when initializing the cache, and it is like a database query going against here. And it's the same code. When the second server starts, it doesn't emit that information because it gets the cache information from the other server, and the check in the code is if the cache is empty, only then load the cache. But For the second server, that is not the case. So basically what's happening is this communication going on between the servers, and they are, if one of the server part of the cluster has the cache, it is sharing it with the other server. So it doesn't start up with an empty cache. It gets the cache information from the other server in the cluster. Now, if I go back to Wiresharks, so AGMP, you see they have a join group, and then after that, you'll constantly see that there is like communication going on between the servers, basically, and the other Wireshark will also represent the same information. So there's communication going on in the two servers. Some packet drop here and there. So now what I will do, I will turn off this server. So this is the first one that is started. So I stop the server, and you should see some error messages where 150 is the source trying to communicate with the one server on 1111, and the server on 1111 is basically as turned off. And both of the Wiresharks basically represent that this information that there's communication going on from 150 to 1111, but they are unable to find the server. Similarly, if we go to the Hazelcast server over here, so tries a few times, gets a socket exception, and finally recognizes that the other server has dropped, and now there's only one member in this cluster. Okay, well, after that there's only one member, and then you will see that these messages on both the Wiresharks will stop, and now there's no more acknowledge trying to find that server, sending packets going on. And by the way, for some reason, the 150 server 1.150 uses those range 5901 to 5904 and tries to communicate it 5801, on which the server was running, and it's unable to find that server. So now if I start the server that I stopped, if I start it again, start it again, you will see again it will start the communication. So while this is starting, and it will not load the cache again, so that's another sign that it is joined the same cluster, and it is not going to load the cache again in the startup. Yep, so you can see it is part of the same cluster. Now this time it's the second member. It used to be the lead, it used to be the first member, now it's the second member in there, and it did not basically load the cache again because it's already in the memory. If I go over here, you should be able to see that it sends a join message. Okay, and by the way, it did send a leave message over here, and you will not see that leave message over here because this one is running on 150, but host on 1111 left the membership, so it dropped off. So you saw a leave group message over here, and even though I just turned off the server, but it still sent that leave message. And when I started it again and again, joined the same server, and then you will again see communication, active communication going on between the servers 150 and 1111. Okay, and this time it's communicating with 5920 to 5820. So 5920 for outbound port for the second server, or is using it's communicating with 5820, the main port of the first server. So these outbound ports are used by server to server communication, and the server that starts second starts communicating with the main port of the first server, which is already in the lead, because that's what it's advertising, that this is my port I'm listening over here. Okay, so if we go to the Wireshark on the 150 side, this is the Wireshark on 150, and it will show you the same information, that there is communication going on from 150, and I do have like router in the middle, which is kind of a bridge in the middle, has its own address, so it's acting on the behalf of the other machine. But you can see that there is communication going on between the two servers. All right, so that's it for the Wireshark and the packet capture portion of it. Now I will turn off the servers and you will see the leave message coming in. First, there'll be a leave message from 150. So there is this leave message because I turned off the server. And there will be packets captured by these two Wiresharks because the other server is going to take on the lead position, and it's going to initially try to basically communicate with the server. It could not, because 150 is down now, so it's unable to communicate with that server. And yeah, since it couldn't find the server, it's going to take the lead position. And I'm going to turn this one off as well. All right, so one last thing that I haven't done so far, I kind of forgot to do, was to run two servers, Hazelcast servers, on the same machine at the same time. So in this machine, which is 192.168.1.1.1.1, I have configured one server, but with two separate configurations, specifically this one. So if I look at the run configuration, so this is the regular Spring Hazelcast server, and this one is running with port 8090. And the difference is in the argument we're providing it the server port that is 8090. So the Tomcat server would not clash over the port with one another. This is just a way to show that people who do not have, say, two machines, they can still run the server on a single computer by providing a different port. So let's just run the one with the standard, the 8080 port. If you don't provide, Tomcat uses the 8080 port. So which is this one over here. So 8080 is being used, and then the other one will run with 8090. So now you have and you will see that it's filling up the cache. So I'm going to run the same program with 8090, and you will not see that this line will appear as before, as it will utilize the cache. All right, so this one is 5801, and it's using Tomcat 8080. And the other one will, since this automatic increment is set to true, will automatically increment the port and will use 5802. So let's run 8090. So now you can switch between the two. It's the original one, and this is the 8090. As you can see, the servers are able to look up one another. And this one is running on 8090 port here. And this one is using 5802. All right. So now you can run the two servers on the same machine if you need to. And then if I run the third one, which is from my local 192.168.150 machine, which is on my local, and I'm not remote desktoping into this. So if I run this one, it will become part of the same Hazelcast cluster, and you will see three servers. One thing you will see over here that you have two servers, and you also did not see that cache load message over here because the cache was loaded by the other server over here. And you can see it emitted out, the first server emitted out 5801, the other one emitted out 5802. And now when the third server comes in, they'll all recognize and be part of this one. So now it's able to be a part of the same cluster. And as you can see now, my cluster has three servers, two running on one machine, 5801, 5802, and the third one is running on 192.168.150 If I switch back to the other one, this one will also recognize that there are 3 servers over here. If you see, this one also does not load the cache because the cache is now distributed across the 3 servers. So one thing which I sort of recently discovered is that if you start 2 servers on the same machine, then you don't have this kind of communication, server to server communication that are going on. It's probably Hazelcast short circuits, something that it just shares the data across the 2 servers on the same machine. Otherwise, it uses the standard protocol is to discover the servers and use TCP to communicate with one another. So if I start 2 Hazelcast instances on the same machine, physically the same machine, so they're not different, so it will not use the TCP standard communication. So there's a message to join the group. So now this machine is interested in it. It's going to join the group and it registers itself like before. Now I'm going to start another instance of it, and this time the run configuration is the same application, but the server port 8090 is what is being provided, so that Tomcat runs on a different port. Now when this machine runs, you don't see any join group again because this machine is already part of it. It's just listening to this group. Okay, and the servers are running in a cluster, but there isn't an active communication going on between the servers as though when they were on different machines. So this is 5801 and 5802. By the way, when you specify auto increment, the server's network address automatically increases. If it sees that there's already a server running on 5801, then it creates another one on 5802. So if I go, I will see that this one is running on 5801. By the way, you will see that 5801 calls database queries to basically fill up the cache, but 5802 does not fill up the cache because it gets the cache information from the other server, and you can see that there is no communication going on between the 2 servers. It's Hazelcast is somehow short circuiting, and it's basically communicating with one another internally instead of sending it over TCP/IP. All right. Now I'm going to show you what parameters cause a Hazelcast instance to be in a cluster or not to be in a cluster. And the parameters that includes are the cluster name, that has to be the same, and the multicast port and the multicast group, they have to be the same. If they are different, the Hazelcast will not form the cluster. So we just saw them forming a cluster. So this time, let's run them, but I'm gonna change one of those values, and you will see that they will not operate in a cluster if the name is different, port is different, or multicast group is different. Okay, so now you have one of the servers running on 5801. Packet analysis for this one doesn't make sense, but they will definitely use the cluster name to look up and be a part of the same cluster. So if I say this just Hazelcast REST cluster 2, and this one is Hazelcast REST cluster, you will see that it's not going to form cluster. So run this. And you will see that they will not acknowledge one another. Right, so now you have this Hazelcast running on 5820. which is this one, but you see it did not, even though it used the same multicast at port and host group, but it did not join the group. So what if we change the port this time, 54320, we change it back, this one, 54321, and you see this one also did not acknowledge the Hazelcast server that came up, the other one. So now let's run this again. So again, you can see it did not join the group, even though it's using the same multicast group, but since the port is different, it's not joining the group. So if I change this, make it back to 0, I believe that's what we had before. And the other one, yeah, also is 54320. We're gonna make it back to 54320. Let's run this again. That should now enable it to join the group, the cluster, the Hazelcast cluster. Right, so you see it has acknowledged, and then this thing should also acknowledge that it has joined the group. So now these two are part of the same group. This one, which is one at 150, and this at 1111. Okay. Now, if I stop this server, you will start seeing starts getting the IO exceptions. All right. Also, there is a program which is running and that loads the cache. And one thing with Hazelcast is that one of them loads the cache, it can load the same information in the other Hazelcast cluster. So if you're running on a different port, you will see, or if it's not part of the same cluster. So let's try this again, and you should see that it's going to try to load some data because the cache, it's not able to get the cache information, as it's not part of the cluster. It's not able to get the cache information from the other instance. So it loads up the cache. You see this message at the end, it comes up filling up the cache because it's not able to get this cache information from the other server. I'll show you the code later, but there's like an initialization of cache that's happening that fills up the cache. But if it's part of the cluster, you will see that this message will not come up. So if I turn it off, and now it's going to be part of the cluster, and it will get the cache information from the other server, and it will not load. You will not see this message of filling up a cache and trying to run the Hibernate to communicate with the MySQL. So now we are running it as part of the cluster. We have all the company configuration is the same, the multicast port group, and as well as the cluster name. See this, it acknowledges that it is communicating and it's forming a cluster, and it is not loading the cache anymore because the cache is coming from the other server, which is already part of this cluster. So this is one thing with Hazelcast. If one of them have a cache, it can provide and replicate that cache information in the other server. All right, that would be the end of this session.